So today's problem is another easy problem. It's the valid anagrams problem. So what is this problem exactly? All right, let's have a look. So given two strings S and T, you gotta return true if the strings are anagrams of each other. Okay, what's an anagram? Otherwise you return false. Okay, it's gonna explain. So an anagram is a string that contains the exact same characters as the other string, but the order can be different. Basically, if you take two strings, let's look at the second example because it's shorter. You have string 1, S is just jar, and string 2, jam. These are not anagrams of each other because one of their characters are different, right? You get JA, and an R, and an M here instead. It's not the same. However, if instead, this is like Raj or something like that, right? These two are anagrams of each other. Why? Because they consist of the same number of characters. They consist of the same characters and the same count of characters. So there's one J, one A, one R. It's an anagram. Let's have a look at another example. Race car and T is car race. Okay, let's have a look. So if we apply the same logic, we're trying to find out if they have the same keys and the same quantity of keys. Well, we can say that in race car, we have two R's, we have two A's, two C's, and an E. And then similarly for this one, well, we can see that we have two C's, two A's, two R's, and one E. Okay, you can see here, we can match this, two C's, two A's, two R's, two E's. Okay? This is what it means to be an anagram. Okay, so how would you solve this problem? Easiest way to solve this problem is with sorting. Okay? I say easiest, but it's not the optimal solution. But I think it's good to see it anyways. How would this work? Let's say S is race car, the first example. T is car race. Okay? We want to solve this, so what do you do? If we were to sort this, let's see what this becomes. It would be A, C, C, E, R, R. A, C, C, E, R, R, right? And for T, this would be similar, where you'd have two A's, A, two C's, C, 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 E, R, R. Now that they're sorted, we can actually compare these sorted strings together, whether they're the same or not. Now we can just do a simple equalities check between the two. Is this equal to this? If yes, then it's an anagram. If no, then not an anagram. That's pretty simple. However, the thing with sort is that the time complexity is actually n log n. If the space complexity is oftentimes of n. And typically in Neetcode problems, when you have an O log n solution, it's common for it to not be the optimal solution. So let's try a different approach then. Let's try an approach that doesn't involve sorting. Then maybe we might have a better time complexity. Another approach that we could do is probably use a hash map, yeah? With a hash map, the hash map is nice because we can keep track of what keys are present in each string and how many times we've seen each character. So what would we have at the end when we have a hash map? It's actually very similar to how I drew it out earlier in the problem explanation section, right? So earlier, I had something like this. Earlier, we had this. This is actually exactly the format that we want, because once we have this structure, we can compare them with each other. You can say that, well, of course, it's out of order, because in a hash map, the order is not guaranteed. Of course, the order could even be different from this. This is just how I choose to order at this specific time. But if you have two hash maps in this format, and then you can have Python compare the two hash maps, and then we would get our answer. If this hash map is the same as this hash map, then we're good. The order doesn't matter. So now that we've figured out like the high level solution for this, but another problem is like, how do we construct the hash map? Because we have to construct the hash map first, and then we'd have to compare them at the end. Now, how do we construct the hash map itself? Okay. We can loop through every single character of both S and T, and then we create this hash map by itself. So the manual method is pretty straightforward. I'm just going to do this example for race car, but it's the same concept. So you loop through each element and then you go R. Is R inside our dictionary? Nope. then we create a new entry. Is A inside our dictionary? Nope, then we create a new entry. Is C inside our dictionary? Nope, then we create a new entry. Is E inside our dictionary? Nope, we create a new entry. Is C inside our dictionary? Okay, now we have it as C. We can actually utilize the O1 lookup of the dictionary and straight away figure this out. Is there a C in our dictionary? Yep. So this goes from 1 to a 2. Is there an A existing? Yep. Then it goes from 1 to a 2. Is there an R existing? From 1 into a 2. You have this. Then you do the same process for T, which will give you this, and then you can compare the two. And that's our solution. So as far as time complexity analysis goes for this method, to construct a hash map for S, it's going to be, well, we have to loop through every element of S. So let's say M is the size of S, and N is size of T. Okay. Going through each element is going to be a linear time, M, and looping through each element of T would also be linear time, so N. And then once we loop through these two and then comparing these two, we'll actually run through every element of this and every element of this. So this is, well, technically it's probably like if you're looking at this, the size of this is a little bit smaller than this. The number of keys is smaller than the number of elements here. But in the worst case scenario, we would have one key for each letter. So looping through each one would also take O of M and N, right? Now, it is a little bit different technically because we have this constraint, right? S and T consist of lowercase English characters. So as we know, how many letters do we have from A to Z? We actually have 26 letters, right? We have 26 characters in the alphabet. And because of that, if you think about it, the size of this hash map can only go up to 26, right? Because unlike our original string, which can go up to like however long it kind of wants, the number of unique characters inside this S is limited to only lowercase English characters, which means that the number of unique characters is only limited to 26. Yeah? Which means the size of the dictionaries can only go up to a maximum of 26. So technically, when we're looping through each element inside our dictionary for comparisons later on, this is actually O of 26. O of 26, because it can only really go up to size 26, right? Right? So effectively, in the grand scheme of things, we don't really care about the things that are constant in time. We only care about the scaling variables. So we'll say it's an O of M plus N, which is a linear time. This doesn't matter. It doesn't factor in. As for the space complexity, well, the only thing that takes up extra space are these dictionaries. And as we talked about, the space complexity for these dictionaries are O of 26, right? You can only have 26 elements at most at any given time. So in the worst case, it's of 26 plus 26, which is the two dictionaries that we have here, which, again, we don't care about the actual numbers. So it kind of averages out to a constant time of 1. Okay, this would be the solution. Let's have a look at coding it. All right, so here's the code. Let's give this a shot. So as we mentioned earlier, our first step is to create the dictionaries. Well, I'll call them dictionaries here because we're coding in Python. So dict of S is going to be equal to an empty dictionary, and T is going to be another empty dictionary. So what we want to do is fill these up, okay? So we have to loop through each character in S and T first. So let's start with S. For C and S, what are you going to do? You got to check whether this character is in here. That's the first thing we got to do. And then if C is not in dictionary S, which means that we've not seen this thing, and it's not in our counters dictionary. So we gotta set the value to 1. Otherwise, it is already in there, and we've already found it. We can find it. We can say that that value, that key, I want to increment the value by 1. Okay, and then we repeat this process. We repeat this process for C and T. Now we're going to say if this is not in dictionary T, then I'm going to set the value to 1, and otherwise I'm going to increment the value by 1. So now that we have this, we have the dictionaries filled up. Great. And at the end of the day, we just have to compare two dictionaries. So dict s, dict t. So if they're equal to each other, then it is true. So we can just return this. They're the same, they're anagrams. If they're different, then they're not anagrams. And that's pretty much the solution. Let's give this a run. Oh, I made a mistake. Oh, there's no is here. I think I'm too used to typing in English. There's no is, yeah. Alright. Cool. So that's the solution pretty much. Yeah, runtime and stuff is pretty good. Cool. Actually, I want to show you like one thing in Python that you can do for these types of problems. There's actually an easier way to do this instead of writing this whole loop to fill up the dictionary. So in Python, we have this thing called counter. And what counter does is that it can take a string or an array, and it will actually create the same data structure that we wanted before. It can create this data structure for us, basically. So if I do counter s, right? I pass in the string or the array as a variable, it will actually give me this. So we don't have to manually fill it up like we're doing right now. And then once we have that, we can directly compare the results because we already have this thing. So let's have a look at trying to use counter. All right, so what I'm suggesting is we can do counter of s. This will give us the dict s, right? What we had before, which is the exact same thing. And for dict t, we can just do counter t. This will give us this thing. It'll do this work for us. So I can just chuck this in the bin. Bye-bye. So I'm going to run it. See how it goes. Well, there you go. It still works. And as you can tell, we don't really need these variables anymore. We can simply chuck them all out. And in the end, we actually have a one-liner. There you go. We have a one-liner solution. How do I feel about this? We wrote a bunch of code, and at the end of the day, we kind of tossed it all away because the simplest solution is a one-liner. I think that's okay, because sometimes maybe you're in a different language and maybe your language doesn't support having a counter. And I think the important thing with these kinds of Neetcode problems is to kind of show your thought process. Like, how would you solve this given the tools that you know, or given like primitive tools and whatnot? Of course, like understanding the language well enough to know that these kinds of utility classes exist is also a show of knowledge. But I think the most important thing is understanding how it works under the hood. Okay, bye.